while we're here trying to transform the country, the world is moving forward too in terms of technology. I remember one of these little, shocking experience about how things could change very fast in the US was about self-driving. Every of our guests are saying that the speed of change in Ukraine is unbelievable. And everything takes forever to change in the United States. It's not quite true. I remember I left Pittsburgh 2 years ago, or a year and a half, to go here on a leave for half a year. I come back, self-driving, not quite self-driving, but self-driving experimenting Uber car in Pittsburgh was at every corner. I actually have a video where at one intersection, within 5 minutes, there are more self-driving cars passing by than normal cars. They are training their cars, of course, but it changed in half a year. It's really, the entire. I'm not saying they're driving them right now fully commercially, but Pittsburgh has become a place for testing these cars. And I've been in Uber, which is self-driving, with 2 people there, just in case something goes wrong, at least 5 times in Pittsburgh. I get picked up by self-driving Uber. Now that changed a little bit, but the future is not as far as we might think. And at this, I'll just, I'm very grateful that Mike is here. Mike is chief economist of Microsoft currently. You were the chief economist at Google Cloud and at Waze. Many of you know Waze as well. And before at Yahoo. And before that, he was at Harvard University. So let's welcome Mike and let him speak about the future of transportation.
All right. So it's an honor to be here, and it's also an honor to speak after Paul Milgram and Paul Klemperer. So I think today you kind of got to see speakers from 3 different generations of market designers. And I think each generation is a little different. So I myself had a benefit of standing on the shoulders of the giants who just talked an hour and 2 hours before me, and I certainly learned a lot from Paul Klemperer and Paul Milgram over the years, both directly and indirectly, and you can learn from them too. In fact, Milgram has quite a technical, very nice book, Putting Auction Theory to Work. And Paul Klemperer has a book that's much less technical and also a delightful read, Auction Theory and Practice. And both Paul and Paul are academics, and I also was an academic early on in my career. I was in the faculty of Harvard Economics department, but very quickly I moved to technology sector, and that is kind of, to some extent, the natural progression of market design that started in academia and kind of outgrew it, so it became important enough to be out there in the real world. And I think the exciting stuff in market design is now happening largely outside of the walls of academia, in part because those technologies that we are creating make those marketplace design algorithmic solutions much more practical, much more seamless. And I think seamless is really a key word. If you have an auction that is theoretically wonderful, but really a pain to participate, a pain to put together technically, well, it probably ain't going to be very popular. So now we are entering the age where a lot of things are possible with a couple of clicks that weren't possible before. This talk is about marketplace design for carpooling and economics of self-driving cars. So first, a word of warning. If you like to be surprised by the future, just close your ears, because I have a crystal ball. I'll tell you what the future has in store and how we are going to bring it to reality. So this is joint work with Michael Ostrovsky, who is a professor at Stanford Graduate School of Business, and I'm Michael Schwartz. Let me start out with kind of just a little bullet point list of 3 emerging technologies that will transform the future of transportation. And Okay. And one of those technologies is technology for self-driving cars. This is really sexy, this is like sci-fi, this is amazing, a robot driving a car. That's something we were, well, some of us were dreaming about it, some of us who are old enough didn't dare to even dream about it, and it looks like it's likely to happen quite soon. So I'm a little bit of a self-driving car skeptic. I think there's there's a lot of real stuff. There's also a little bit of hype. So for example, you see Google testing the self-driving car, you see Uber, you see a number of other companies playing this game, including Baidu in China. Well, none of those companies actually have a commercially available self-driving car. Well, guess what? None of those companies actually have a prototype self-driving car that is driving around without a human safety driver inside the car. Well, I'll tell you a little bit more. In fact, none of those companies will disclose to the public how many times that driver in that car had to interfere and take control over the car. Well, casual observation shows that drivers had to touch a steering wheel very rarely. They pretty much, well, more or less never do. But guess what? If they have to interfere only once a day for 1 minute, well, if they weren't there, that would be one fatality a day. That's a little too many, I would reckon. So it will take a little while to get that technology perfect enough so that self-driving cars are truly safer than human drivers, and I think one day they will be. But we are not quite there yet, but we are really getting there. So this is an important, sexy technology that will transform the world. There are two other technologies that are also emerging, that are also almost there. Basically, all the ingredients are there. It just remains to work out little kinks. And those two technologies, people don't write about. People don't talk much about them. And I think they are just as important for the future of transportation, if not more so. And that is technology for frictionless, time-dependent tolls. By tolls, I simply mean you drive on a road, and for each segment of the road, you have to make a payment. That payment may depend on the time of the day. During rush hour, it's a lot more. Off hours, maybe it's free. That payment is not something you just have on the main road. You have it on many, many roads. It's ubiquitous, and it's completely seamless. You never have to slow down to make a payment. You never have to think about it. It's just something that happens automatically. Just like when I pick up my phone to make a call, I still remember the days when I was, 5 years old, where, when you make a call between cities or between countries, you get a price quote, you make an advance payment, there's a lot of hustle involved. Now, well, we just pick up the phone, we make a call, there's maybe some small charge involved, and it's seamless, right? With the tolls, again, I expect that tolls would become completely seamless. And the other technology is technology for convenient and efficient carpooling. That is enormously important. And people don't talk much about it because obviously carpooling has been around for ages. What is carpooling? Carpooling is simply one person is going somewhere and another person wants to go roughly to the same place. So he hitches a ride, he makes some payment, and both driver and the passenger are better off because of that, right? So why is carpooling so important? Well, there are several reasons, but one of them, if you just think in terms of economic value, if we could have a carpooling platform where, say, we put an extra passenger in just one car out of 10, it doesn't sound like that much, right? So the economic value of that would be greater than all the oil fields of Kuwait combined. In fact, it would be more valuable than all the oil, all the gas, and all the coal in entire space of the former Soviet Union. So there's a lot of value. So again, I'm talking about obviously worldwide carpooling platforms. So if you were to do it worldwide, that's what it would mean in terms of economic value. And it's like, isn't that an overstatement? How could that be true? Well, it's very simple how it could be true. So first of all, if you get 10% of people carpooling, you save somewhat an order of magnitude of 10% of world's fuel. It's not quite true because there are also trucks. Passenger cars is not the only consumer of gas. But you would be saving upward of 5% of fuel by getting 10% of people carpool. But that's not where most of the savings come from. Because when you drive, the cost of gas is just one of many costs. The depreciation of your car itself, is another cost that's really, really large. That's actually larger than the cost of gas. So that's where enormous savings would be coming from. So if you can get people to carpool, the economic value is tremendous, and some of those values comes from you need fewer cars, there's less depreciation on the cars that are not being driven because the owners carpool with someone else, and you save gas, of course, you save parking spots, and very, very importantly, you also reduce traffic. You use the road capacity more effectively because now you have one car instead of two, or maybe one car instead of three. So, so obviously, this is tremendously economically important. And why are tolls so economically important? Some people say, well, a toll is kind of like a tax, right? Just the government is starting charging me for what I need to do. So, well, how is it different from a tax? Why is it economically efficient to charge motorists for driving on a congested road? They are punished as it is by wasting time in traffic. Why punish them one more time by charging them for it? Why would that? Well, obviously, that would be great for people collecting tolls. That would be a big source of government revenues. But would it be good for motorists? So you would see that it actually would be good for everybody, and it would create a lot of economic value if we were to implement the system of frictionless time-dependent tolls. But I'll talk later about why. But before I get to that, I want to do a little quick poll. So please raise your hands if it's kind of obvious to you why there is tremendous economic gain, tremendous efficiency gain from charging tolls. And raise your hands if it's quite unclear to you why it would be such a good idea to charge congestion tolls. Great, thank you. So I have a lot of souls to convince, and that's actually one of the obstacles to getting tolls to become reality. But there's another obstacle. And I'll talk about that other obstacle, other than basically public mistrust of tolls. There's another purely technical obstacle that I'll also talk about later. But all that begs two questions. What will a market powered by those three technologies look like? And how should that market be designed and organized? So let me do a quick outline of the talk. I will talk about those three emerging technologies and interactions among them. I will talk about main model and results, and for main model and results, I will flash a few theorems and a few proofs, but I'll largely skip them. And there's a paper available online, so if you got really interested in that, consider it as an advertisement teaser. You can read the paper, which will describe everything in gory details, but here I'll just kind of gloss over those things. And if time remaining, which it never does, I will talk about auxiliary result, about benefits of high utilization of cars, due to self-driving, due to emergence of self-driving cars. Actually, let me elaborate on that a little bit here. So, people are already starting to think, what would the world look like when self-driving cars would become available? And currently, the prevailing view, so you can certainly imagine a world where simply, instead of buying a regular car that many people do today, you would be buying a car that is a self-driving car. So you still own your car. It's just that when you get to go to work, you press on the button that says work, and then you lay down in the back seat and take a nap or watch a video, and then you arrive and you park the car at the same place where you always parked it, and pretty much nothing changes other than the fact that while you drive, you sleep or watch videos. So that's one possibility. Most analysts think that this is absolutely not how it's going to be. So the prevailing view is that self-driving cars will be available as a service, not something you own, but something that you hail through an app on your phone. Self-driving car arrives, it gets you where you need to go. At that point, you say goodbye to the car, and the car goes to the next passenger, picks him up, delivers him, and waits for the next passenger. So that's kind of the prevailing view of what the marketplace for self-driving cars would look like. So obviously you can see some of the benefits. You don't have an extra hassle of car ownership. You need a lot less parking. You utilize cars much more intensely. All of that is true. So the question is, would that be pretty much the only model according to which people would use self-driving car, or would that model coexist with ownership, private ownership of self-driving cars, where they're just used by one person and not really shared? My personal view, which is somewhat of a dissident view, is that, in fact, we will see coexistence of ownership models. And we will see them, self-driving cars, both as a service, but also we will see them owned individually. And if I have time, I'll talk about why I think that to be the case. So let me talk about tolls a little bit. So current technology for tolls, things like what we call in the US Easy Pass. You have a little transponder in the car, and you drive by kind of a massive gate like this that detects that your car passed by it. Oops, sorry. Oops. And you either don't have to slow down at all, so you go full speed, or you have to slow down a little bit. And even at, say, 40 miles an hour, or maybe even at 65 miles an hour, just transponder send the signal, everything is registered, electronic payment is made, and you're done, right? So this is kind of current state-of-the-art technology. I wouldn't say it's current state-of-the-art. That's current most common technology. And this technology is absolutely fantastic relative to the tolling technology that was used in ancient Babylon. So it happens our first references of road tolls do date to ancient Babylon, which is ironic because also our first reference to actual auctions also date to ancient Babylon. So, to be sure, they weren't auctioning off the passage through tolls. In ancient Babylon, they were auctioning wives, but that's a different story. Marriage markets work differently in different civilizations, but certainly I don't exactly know what ancient Babylonian tolling technology was like. I imagine it did not include an electronic transponder. I imagine you did have to actually do a full stop and make a payment to someone who was probably armed, but not dangerous. Obviously, having those transponders is a really good thing relative to tolling technology, where you have to stop and pay cash to someone who is standing on the side of the road collecting toll. No question about it, big advance. But guess what? The new generation of tolling technology that is currently already technically feasible and is already deployed for tracking in parts of Europe is as much ahead of this kind of tolling technology as this tolling technology is ahead of Babylonian way of collecting tolls. Why is that? Well, this tolling technology is actually quite terrible. I mean, great compared to ancient Babylon. Well, great compared to tolling technology of our childhood, which was identical to ancient Babylon, but still terrible. Why is it terrible? Because putting physical infrastructure on the road that detect your transponders is really high maintenance, expensive, not practical. And it makes it difficult, really impossible, to have ubiquitous tolling. So what you can do with this technology, you can have tolls on huge bridges, major highways. Could you have a toll at every street intersection? Could you have a toll at every highway entrance or every highway exit? Absolutely not. This is just way too expensive and not practical for that. But in order to have congestion tolls that are economically efficient, you couldn't just have big tolls on a couple of points on major highways, because then what you do in many instances, it simply means people would reroute themselves. You would create a lot of traffic elsewhere. So as someone who is a former chief scientist for Waze, I know something about rerouting people. So that is not really a practical way to defeat traffic. You could not use this technology inside the city if you want to make, if you want to get rid of traffic congestion in the city. You need tolls on literally every city street. So by the way, why is tolling technology so great for reducing traffic? So let me give you kind of a very stylized argument, and I will come back to this argument later in the talk, but let me give you a very quick stylized argument. So let me start with kind of a little analogy. So some of you here who are old enough were born in the Soviet Union, and some of you here who are old enough remember the lines that you have to stand in order to buy, say, beef in a state-run supermarket. Well, in the Soviet times, you have beef that's underpriced. Okay, grocery store. I stand corrected. Lines were what? Toilet paper. Even better. Thank you. Toilet paper. Actually, there were. Well, the only reason why there were no lines for beef is that there was no beef. But okay. But when there were lines on rare, joyful occasions. So toilet paper. Thank you. Very good example. So you have toilet paper that's basically underpriced. So how do you allocate it? They say, well, there's a price of the toilet paper, but at that price, there are more people who want toilet paper than we have toilet paper available. So, well, what happened then? Well, what happens is that we are going to run out of toilet paper. Okay, so the guy who kind of came too late didn't get any. So if you want to get that toilet paper, you have to stay in line. So what you pay for that toilet paper is the price of the toilet paper plus the cost of your time that was required in order to procure that toilet paper. So the true price of the toilet paper is not the state price, because it's simply not available at state price. You couldn't pay 0 minutes and 30 kopecks in order to get that toilet paper. What you need to do, you need to pay 30 kopecks and 20 minutes, and then you can get 8 rolls of toilet paper, but you couldn't get 16 because obviously you can only buy 8 if you stand in line once. Well, you can stay in line twice and then you could get 16, but then you pay your time twice, right? So that's loosely the allocation system. Now, and it looked pretty sensible back in the Soviet days. You know, most of us who didn't know about markets or weren't born then didn't necessarily think that there was kind of an obviously better solution. And of course, today we look at it and we go like, that is really loony. I mean, why waste so much time on getting toilet paper? It would be really, yeah, we have a limited amount of toilet paper, but still would be better if you kind of increase the price to market clearing price so that everybody could buy it at that price. And some people would choose not to, but it would be too expensive. That's fine. They will use newspapers because some of the people will end up using newspapers. I mean, what else could you do? There's limited supply of toilet paper, just like there's limited supply of the road. Well, that seems like a better way to do it. Nobody today doubts it. So guess what? Right now, today, we are doing the same kind of craziness with road as the Soviets did with toilet paper. Why? Well, there's limited supply of toilet paper, so they allocated it by low price plus the cost of your time that some people will end up spending. What do we do with the road? The same thing. Just like there was a limited supply of toilet paper, limited number of slots, we have limited supply of road capacity. And we allocate that at 0 price. You don't have to pay anything to drive on the road. There is no toll. But you have to pay with your time. Or in some places where there are tolls, typically tolls are actually quite low, so you still have to basically stay in line during the rush hour. So it's exactly the same problem. And it's obvious to us that it's a really bad idea to underprice toilet paper, but somehow most people still think it's a good idea to underprice road capacity. That's a scarce resource, just like toilet paper was, and is, by the way. We don't feel the scarcity because the price is high enough, so the market clears. So very few people today would say, well, wouldn't it be lovely if toilet paper were half the price and the lines would be 20 minutes to get it? Nobody thinks that. So our children would look back and say, crazy shit was happening in early 21st century where people would stay for hours just to get from A to B, wasting all that time. So that's what the future will bring. I'm quite certain of that. And of course, it unlocks tremendous efficiency because first, when you charge tolls and make road less congested, the capacity of the road actually increases. You can actually get more cars per hour through the road if there's no traffic, if tolls are high enough that kind of the traffic just flows but doesn't get jammed. On a jammed road, the capacity becomes really low. So you actually increase capacity of the road by charging tolls. That's one benefit. The other benefit, the cost of the time that people were spending anyway waiting to get the unit of capacity, now people are paying in cash, and they don't have to wait if the toll is sufficiently high. So people are saving a lot of time because of tolls, and that's actually a wonderful thing because when you pay with your time, that time is lost forever, for you and for the mankind. When you pay with money, that money actually could be used for something. That money could be used to build a school or build a new road so there would be less traffic. So time spent in traffic paying for this resource, for scarce road capacity, wasted forever. Money spent paying for road capacity, that is something that could be put to good use, or stolen by greedy bureaucrats. But even that is arguably better than just entirely wasted. Because if greedy bureaucrats would steal money from tolls, maybe they would steal a little bit less from something else. Okay, so this is kind of the tolling technology that's coming soon. And those are satellite-based tolling systems. And the reason that they're called satellite-based is because they rely on GPS technology that in turn is satellite-based. So the wonderful thing about the next generation of tolls is that you don't need to have any hardware anywhere on the road, zero whatsoever. Or you can have extremely small amount of hardware on the side of the road, depending on implementation. But you can always even do it with zero hardware on the roads. And you can have tolls at every single road segment, every single block. You can set a toll. And for some blocks the toll could be zero, for some blocks the toll could be positive, but you can really have tolls anywhere and everywhere. And it doesn't cost you anything extra. Like with current tolling technology, right, with things like EasyPass, you want to put 20 tolls instead of 10, you basically spend double on hardware. Here there is no extra hardware. You want 1,000 tolls instead of 10, and the cost of physical infrastructure for that is exactly the same. So how does it work? Well, it's kind of, well, in some ways it's quite complicated, but conceptually it's extremely simple, right? All of us have a phone in the pocket, and that phone could collect your location information. It could see if you are driving. If you have an appropriate app on that phone, it could basically figure out where you were and charge you appropriate tolls. So that's basically the essence of satellite tolls. Obviously, you have to make the system robust so that people couldn't cheat and so on and so forth. But I will not dwell on those important technicalities here. The important thing that it could be done, and it will be done, and it's currently being done. With carpooling, we also, carpooling technology was around for a long time. And the most traditional carpooling is, well, you're a college student, you put a little card on your bulletin, on some kind of bulletin board in your dorm saying, I'm looking a ride from here to there, who could help me? Well, that's not a very efficient carpooling technology. That's pretty bad. Well, there's the next generation of that. You write an email to all your colleagues and say, hey guys, who could carpool with me? Oh, that's a little better, but still extremely costly. So let me give you a little bit of a sense of how costly this kind of undirected communication is. So actually, raise your hand if you, I guess we are in downtown Kyiv, so probably not many people drive. Raise your hand if you drove here. So a decent number, so you can probably give a ride to someone. But even if you didn't, so we had probably like a dozen people who drove here. So guess what? I would imagine that for each of those 12 people who drove here, there's probably at least one person in this audience who are going in the same direction where at least one of those 12 people came from, right? So there are carpool partners for you here, potentially. But you are still going to go home by yourself. You're not going to give anybody a ride because the overhead of finding those carpool partners is too high. And even if you had magically an email list where everybody could start sending emails about it, you know, if one guy says, who could give me a ride from A to B, and every single person gets that email, and everybody spends 10 seconds deleting that email, well, there are like about 100 people here, so we are talking about already 15-minute time expense from the community. So even if that person successfully found a ride, the community paid 15 minutes of time to arrange that ride. Well, that's way too expensive for a single ride. So that's why we don't see much carpooling. So what you need a carpooling technology that would really make finding a carpool partner completely seamless, so that it doesn't take community 15 minutes to find you a ride. It needs to be so well targeted, the system has to be so intelligent that the total time cost of for the entire community, not just for people who are carpooling, but also for everybody who chose not to take that carpool, the time cost has to be down to like a couple of minutes, and then it would be really practical. And for that, you need to do a lot of clever tricks that we now can do because we have GPS-enabled cell phones in our pockets that know where we are, that know our habits, that could guess who is the likely carpool partner for us. So if that technology is smart enough, you can really do very seamless carpooling. And there are several carpooling platforms out there, and Waze Carpool is one of them. It's fully launched in Israel. It's partially launched in the US. It's still not entirely seamless. There are little kinks around the edges, but it's kind of almost there. There's another carpool platform called Scoop that also tries to do something similar. So there are a number of companies that are basically doing a lot to make carpooling more and more seamless, and it's coming. So how do those three technologies interact? Well, I think they interact in quite interesting ways. They kind of feed off each other. So information technology, advances in information technology are powering all those three technologies. Self-driving cars would not be possible without AI and IT. Tolls will not be possible without it. Carpooling will not be possible without it, because again, tolls are very inefficient without advanced information technology. But once you have basically GPS-enabled tolling solutions that are completely seamless, combined with seamless payment solutions, tolls suddenly become very efficient, and it's all driven by advances in information technology. Carpooling is the same thing. Very large overhead of finding a good carpool match goes lower and lower because of advances in information technology that creates more and more seamless, efficient matching. So you can see all those three circles being powered by advances in IT, but there's a little bit of a virtuous circle going on there. So self-driving cars, when they become available, would make both tolls much more economically attractive, and would also make carpooling more economically attractive. So self-driving cars will give a boost to both tolling adoption and carpooling adoption. And tolls and carpools are also technologies that are complementary to each other. They're feeding off each other. Why would that be? Actually, raise your hand. Raise your hand if you see why self-driving cars would make tolls more attractive. Raise your hand if you see why self-driving cars would make carpooling more attractive. Awesome. I wouldn't have to talk about this one. And raise your hands if you see why carpool will make tolls more attractive. And raise your hands if you see why tolls would make carpooling more attractive. This one is not too popular. I'm surprised. OK. So let me kind of elaborate about each of those arrows, because I think for each of them we got less than 50%, about 50% of people see things that are obvious, and 50% of people are not so sure. So once self-driving cars become available, Tolls would become more attractive first because if self-driving car is available as a service, then, when you hail self-driving car, you kind of know what the price of the ride is, so it's much easier and more seamless to simply build in that toll in that price. So it's a matter of user experience, as a matter of kind of political objections, there's a lot less, you would see a lot less of that. There's another reason. Once you have self-driving cars, something terrible could happen. And if you have a self-driving car, you can sleep in your car, you can watch videos in your car, and that means that you can tolerate a longer commute. Well, if everybody could tolerate a longer commute, commutes would get longer. Well, if commutes get longer, traffic would get worse. Well, if traffic gets worse, commute gets even longer. But that's not a good equation. That's terrible, right? That could do a lot of harm. And that's very, very real. In fact, I just recently saw an article about some businessmen in highly congested second and third world cities, both in Moscow and in India, and possibly in Kiev too, I don't know, basically buying up Mercedes minivans, turning them into luxury offices, and basically driving around town in that mini office, where they end up spending most of the day simply working out of their mobile office. They have a chauffeur, the chauffeur does the driving, they have a fax machine, they have a couple of phones, they have fast internet, they have everything. They have comfortable chair, leather couch, all of that in a car that's driving around the congested city, right? So, well, you don't see much of that because today you need to buy an expensive driver in order to do that. Well, if there's a self-driving car, a lot of people would start doing that because the cost of driver is gone. And, well, what would that do to traffic? Well, nothing good. So once you start having this problem developing, you'll say, well, to discourage traffic, to get less traffic, we have to introduce tolls. So self-driving cars may also become kind of a trigger for having to introduce tolls. And with carpool, I think obviously, with self-driving car, there are many reasons why carpooling becomes a lot easier. I'll talk about it a bit later. So, very, very important points why carpool makes tolls more attractive. So there's a lot of political opposition to tolls, and some of that opposition is really wrong-headed, and some of that opposition is very sensible. And one sensible objection to tolls is that if all of us had time that costs the same amount, then probably it wouldn't be such a big problem to have tolls. It kind of would be on some level fair to everybody. But some people have a lot more money, and some people have those people have a lot more expensive time, and those people would easily pay the toll. And then the poor people will basically have to drive to work at 4 o'clock in the morning because tolls are very expensive during rush hour. So if you want to get a cheap toll, you have to go to work really, really early. So then the poor people who are already poor would be even worse off because of tolls. And from distributional point of view, that is really not a good thing. And it doesn't feel very fair when you have when you have an instrument that maybe makes a society overall better off, but it makes rich people a lot better off because instead of wasting a lot of time, they just pay a little bit of money. That doesn't mean that much to them. But it makes poor people a lot worse off. Not quite as much as it makes the rich people better off. So you can imagine solving this problem by simply giving some kind of tax rebate to poor people who get kind of screwed by tolls. But that's easier said than done. So there's there's a real problem with tolls. But if a seamless carpooling platform is available, that largely solves this problem. It makes everybody better off. Because if you have this expensive toll, the choice of a poor person who needs to get to work, so if you just have tolls and no carpooling, if you have a relatively low-income individual who drives to work, once there are tolls, he either have to pay a lot of money for the toll, and since his time is relatively cheap, he used to pay for access to the road by simply standing in traffic. He used to waste 30 minutes every day, but his 30 minutes were relatively cheap because he's not making much per hour. So now he has to pay for the same 30 minutes at a rate that's higher than the value of his time. So now he's worse off. He's saving 30 minutes, but he's paying more than the value of his time. He's worse off, right? So one solution, one kind of course of action for that poor person would be to pay the toll and basically be worse off because of that. He saved time, but the amount of time that he saved is not enough to compensate him for the toll that he paid. Unlike the rich guy who's also saved time, but his time is more valuable, so he's much better off, right? So the other solution for a poor person or lower middle class person would be to simply avoid paying toll by going to work really, really early before rush hour. That may be an acceptable solution, but that again may be making that person worse off relative to simply going to during rush hour and wasting 40 minutes in traffic, right? But if you have carpooling solution, there is a third option. You can say, you know what? I'm not going to drive. I'm just going to carpool with someone, and this way we are splitting the cost 2 ways, or maybe even 3 ways if I'm carpooling with 3 people. And this way, I'm still spending less money than I used to spend on driving. I'm better off. And I'm also better off in terms of time, because even though carpooling takes a little bit more time than driving solo, since there's no traffic anymore because there's a high toll, I'm actually saving both time and money because of this combination of toll and carpool. So that's why carpool makes tolls more feasible. Or there's also a third option for a relatively poor person. He could drive, but he could drive in a carpool, and this way he pays only half of the cost of driving, and he pays only half of the cost of toll, and then again, his cost is virtually the same as it was driving solo and not paying toll, but he saves time because of tolls we can get rid of traffic. So that's why there's this huge complementarity between the two. Good carpooling platforms make tolls economically feasible and makes everybody better off, not just part of the population. So I have about 10 minutes left, okay. So let me talk a little bit about complementarities between autonomous transportation and carpooling. So in the world with self-driving car, carpooling will blur the line between self-driving and public transportation. So currently, the cost of driving is a significant component of transit costs, the cost of drivers. And that is why public transportation relies on pretty large vehicles. We have big buses. And the reason that buses are big is because drivers are expensive. So with self-driving car, the cost of a driver becomes much, much lower. So we should expect that the cost of self-driving unit, when the technology matures, would be probably less than 1/10 of the cost of the driver, right? So it becomes really, really cheap. And that would enable much smaller, so right now public transit is, since drivers are expensive, you have to have large vehicles. And since you have large vehicles, you have to make lots of stops because you don't have large number of people who go exactly from A to B. So once you eliminate the cost of the driver, You can have smaller vehicles that make fewer stops, and also, unlike the bus system where you kind of connect different buses and so on and so forth, it's not door-to-door. If vehicles are sufficiently small, well, you can have door-to-door transportation. It becomes kind of an on-demand shuttle. And I think that's kind of the future, where essentially you would have this transportation as a service on demand, door-to-door, but with multiple people involved and with small detours for each of them. So it becomes kind of sort of like public transportation and sort of like a taxi or personal car. So another complementarity between autonomous transportation and carpooling, we'll have no hassle coordination. The reason is that self-driving cars have to know the destination, right? So typically, if you drive a car, you know, some people use navigation apps where you say, I'm going from A to B, here's my destination, I'm going to B, in which case there's some system that knows where you're going. But most people don't bother. Most people know how to drive to B, so they just jump into the car and they start driving. That's it. And nobody knows except for them where they're going. With a self-driving car, that is no longer possible. You have to tell the car, I'm going to work. Maybe you have to tell it with your voice, maybe with buttons on your phone, but somehow you have to communicate to the car where you're going. Well, once you did that, the car knows it, and it could start seamlessly looking for a carpool partner for you because it knows the destination. That makes coordination a lot more seamless. There's also, with self-driving cars, and that's really important, there's no loss of flexibility. Let me elaborate by what I mean here. If someone has a relatively long commute, one of the problems with carpooling, let's say you get to work with a carpool partner, and now you need to go back. And maybe you have a pre-existing arrangement with your carpool partner that both of you will go back at 6. Well, that's way both of you completely lost flexibility. Your carpool partner couldn't say, oh, I need to work till 7 today. Because then he's screwing his friend who is counting on picking up his kids from school at 6:15, right? So there's a loss of flexibility involved, at least for one of the parties, right? So maybe there's an agreement, I carpool with you, on the way back, I will just accommodate you. I'll go back whenever you want to go back, in which case I'm losing flexibility. I have to be on your schedule. If there are self-driving cars, they create a relatively inexpensive option for going solo. So even if you came to work with carpool, if you really need to go early or late, well, there's now an inexpensive option of picking whatever time you want, hailing a self-driving car. If there's a carpool partner available, great, you split the cost. But if not, there's still a reasonable cost of getting home. Today, you can do the same thing with a taxi, but taxis are very expensive, and self-driving cars will be about 4 times cheaper than taxis. So that's a really big difference. And the reason is that taxi, you have to pay the driver for the driver time, and with self-driving car, that cost largely goes away. So the other reasons why kind of self-driving cars would usher the world of carpooling is that detours are much less costly, for obvious reason, because if you're driving yourself and you need to pick someone up, well, you need to enter in the navigator where you're going, then kind of the unfamiliar streets, it's a little bit of a stress to look for a place and so on and so forth. If you're in a self-driving car does the thinking, you're just sitting in the backseat reading the paper, you don't even know that self-driving car is like trying to figure out the best way to find the passenger. That's between the self-driving car and the passenger, and the second passenger, you're not involved in that transaction. You're just chilling and watching a video. So the other issue is one of the key challenges in creating a carpooling platform is getting to a critical mass where on-demand carpooling is reliable enough to be practical. And with transportation services powered by self-driving car, this issue is just basically automatically resolved. It just goes away. with several people sharing a ride, it doesn't have to be the case that the same person is the first one getting in the car and the last one getting out of it, right? So right now, if I'm carpooling with you, it has to be the case that, like what we couldn't do, right? I couldn't drive off from my house, pick you up, then drive to your work, get off my car, and then you will keep driving to your work. That just doesn't work, right? Because like, we are not going to swap who is the driver. With self-driving car, there's no issue, right? So you can totally do that. With self-driving car, you don't need to depend on potentially unreliable carpool driver. There's consistency of experience. There's no need to worry about being matched with an unsafe driver, and so on and so forth. So now let me talk a little bit about autonomous transportation and the road pricing. Equilibrium effect of self-driving cars on road demand in the absence of road pricing is a little bit ambiguous. This utility of being stuck in traffic goes down, demand could go up, and hence more traffic. We already talked about it. So intelligent road pricing becomes more necessary. So I have about 5 minutes left. So let me quickly wrap up here. So let me first emphasize once again complementarity between carpooling and road pricing. So let's imagine the following hypothetical situation. Let's imagine that the actual cost of driving is zero, right? So the gas is free, the car depreciation is next to nothing. That's not the world we live in, but actually, in some ways, it is the world we live in if you live in a congested city and your commute to work is 3 kilometers. Driving 3 kilometers is really cheap. There's almost no gas involved. I mean, riding 30 kilometers, there's a lot of gas. But 3 kilometers, there's not much gas. There's not much depreciation over 3 kilometers. So if you have a short city commute, the cost of driving is almost nothing. It's very low. There may be a high cost of parking, but if parking is available, the cost of driving is really low. So what would be, but you may be stuck in traffic in a city like Bombay. 3 miles could take you 30 minutes or 40 minutes or an hour because the traffic is barely moving. So let's say in a city like that, I would tell you, look, I live 3-minute drive from you, assuming there's no traffic. With traffic, it would be 15 minutes. And I work right together with you. Shall we carpool? And they would say, no, we shouldn't carpool because I have a car, you have a car, the cost of driving is basically nothing. For me to pick you up, it should take 3 minutes without traffic, but it would take 15. And the benefit is nothing. We didn't save anything by carpooling. We really helped the society because now we took 1 car off the road, so a little bit less traffic, but it doesn't help you and it doesn't help me, right? Because we are saving very little. So once you introduce, so there's no incentive to carpool. So we are all going to be stuck in traffic. So now let's imagine we introduce tolls. And since we are stuck in traffic for 40 minutes to drive those 3 miles, the toll would be quite high. The toll would be approximately equal to the value of 40 minutes of the time of an average motorist. That's what it would take to get rid of traffic. So once you have that toll, suddenly I go like, hey, Tim, let's carpool. Because now, yep, Tim says yes. Because the toll is really, really expensive now. So we'll split it halfway, so we'll save a lot of money by carpooling together. And that's awesome. We are going to do that. But not only the two of us are going to do it. First of all, Peter also will join us. But second of all, a lot of people would do the same thing, so people would start pairing up, and the traffic would disappear. And that makes a huge difference. So that's where kind of this huge efficiency enhancement from tolls, because tolls encourage carpool. So main model and results. I'm actually going to completely skip that section. It's very technical. It has a bunch of theorems. But it does something that I think is really important. First, it shows how carpool matches should be priced. And it shows that there's actually a very elegant way to solve that complicated market design problem. Second, it shows how to set tolls at efficient levels that would be just right to basically get to market clearing price, just right to get rid of traffic. And some of the kind of obvious/non-obvious results there is that if you set tolls at efficient level, two things has to be true. A, every time when a road is under capacity, meaning there's no traffic. There's no traffic and you're kind of, well, there's no traffic. Right? There's enough capacity to put an extra car on the road and it wouldn't slow down everybody else. The tolls, if they're set efficiently, has to be 0. So most of the time, most of the roads would have 0 tolls. It's important to have a tolling system that allows you to charge a toll anywhere, because when the road does become congested, you do want to have tolls there during the times when it's congested. But you want tolls to be 0 or the rest of the time. So most of the time, tolls would be 0. What you want when a road is at capacity, when tolls are positive, what you want to set a toll at a price that is just high enough so that traffic is flowing freely, but just low enough that the road is very close to full capacity, right? So it's not good if you set the toll so high that half the road is empty, just as like it is not good if you set the price of toilet paper so high that half of it ends up being unsold. So that's basically kind of a very basic nutshell summary. So it turns out, well, you also have to think how does it all interplay with carpooling. Basically we show how to put together a platform where we have absolutely computable ways of doing it. And actually right now, to my knowledge, Microsoft is the only company that kind of could offer the solution where for any interesting buyer, we can offer a solution for tolls where we could compute what the tolls should be for every hour to be basically at roughly efficient level. So thank you, and I wish you a very interesting future.
All right, so thank you very much. We have time for one question, really for one. Are there any questions? Yes, please. We need to get a mic if we have a mic. Oh, so there's no, the question is about air transportation. If there's air transportation in the future.
Oh, I see. So basically, yeah. So first, if I understood your question correctly, if you have flying cars that could go basically from the roof of your house to the roof of your job, would we have problems with air congestion? And that's actually a really good question. It's completely unrelated to the present paper. And the answer is there are different views about it. Some people actually think that you could have quite a bit of congestion even in the air in a crowded city. And some people think that you can pack a lot of things. That all depends on kind of what's the required margin of safety. Is it okay? Do we have to be 300 meters from each other to be safe? Or is it okay to be 30 centimeters from each other because our technology is so good, we'll just fly by? So the answer is, I don't know. I'm not an aerospace engineer, but I know something about traffic on one-dimensional arteries in two-dimensional space. I don't know anything about three-dimensional spaces.
All right. Thank you very much. At this we conclude. Thank you very, very much for coming. We'll give a round of applause to all our speakers, and with Mike including.